Okay, so today what we're going to be doing is we're going to be looking in this video how to come up with an equation for a model, meaning from a set of data or from a story problem, to represent that situation. Now, we've been talking about this form, y equals a times b to the x power for exponential functions ever since the beginning of this chapter. Now, we know that b represents the growth factor, and we know that when b is greater than 1, it represents exponential growth. And we know that when b is between 0 and 1, it represents exponential decay. Now, one way to find a is going to be the value of y when x equals 0. Well, let's think about why that is. So to find out what a is, if x was 0, we would have b to the 0 power. And remember back from chapter 1, the 0 exponent theorem tells you anything raised to the 0 power is 1. So this would mean that we would have a times 1, or a. So when x equals 0, y equals a. That's where they're getting at from this sentence. Now that's going to be important for what we're going to be finding today, because in today's lesson, they're not going to be telling you straight up what the initial amount is. You're going to have to find that out. So in this one here, we know that, well, let's just read the paragraph. It says, find an exponential model to fit the drug absorption data from the table using the initial condition and one other point in the table. So this is, first column represents the hours since the drug was administered, and the second column represents the amount of drug in the body after a certain amount of time. So after 0 hours have gone by, there's 1,000 milligrams that were administered, and that's in the body, so that's how much was administered at the beginning. After 5 hours, that's diminished because the body's been absorbing it. So now there'd be 550 milligrams. All the way down to after 30 hours, there'd only be 31 milligrams in the body. So we're going to use this information to come up with a equation where we could figure out how much or what amount of drug would be in the body after any certain amount of time. So this gives me 5, 10, 15, 20, 25. This gives me every 5 hours. But let's say if I wanted to figure out how much of the drug would be there after 12 hours. Well, I'd have to guess if I looked at this table, so I want to have an equation that would give me more of an exact answer. So here's how we figure that out. Our goal is to put it in this form. So we need to figure out what is A equal and what is B equal. X is going to represent the number of hours since the drug was administered. Y is going to represent our total amount. So that's why we need to figure out what A and B are going to be. Remember, A is when X is 0. Well, I have that right here. So the initial amount is going to be 1,000 grams. However, B, our growth factor, that's what I need to find. So let's plug in first what we know. We know that it's going to be in this form, y equals 1,000 times b to some exponent. So our goal is to figure out what that value for b is going to end up being. So once I figure out what our initial amount is, my next step is to figure out what the value of b is by picking any point in this table. It doesn't matter which point I use, but we're going to pick any point and put it into this equation that I have right here in purple and solve that for b. So here's what I mean. Let's say if we use the 0.5 and 550. Say if we use that one. Again, we could have used any pair of these numbers, but let's just say I use 5 and 550. So that means when x is 5, so 5 hours after the drug was administered, there's going to be 550 milligrams left in the body. So I'm going to put 550 in for y. And 5 in for x. And I'm going to solve this equation. So my first step would be to divide both sides by 1,000. Well, when I do that, I'm going to write it like this. I'd have b to the 5th equals 550 divided by 1,000 is 0.55. And we learned back in chapter 8, it's chapter 7 or 8, I can't remember which one now, but to solve this for b, we would take the 5th root of both sides. So the 5th root and the 5th power undo each other, So I'm left with the fifth root of 0.55. When you do that in your calculator, you get approximately 0.887. So that's my value for b. So now I know now that b is going to be 0.887. So my answer to this problem is going to be y equals, because the y and the x are going to be our variables, y equals our initial amount, 1,000. Our growth factor is 0.887 to the x power. So that's how you're going to do these. Now sometimes they'll give us our information in tables, sometimes they'll give it to us in a story problem, but for right now we're going to look at tables here. So it says a table given the percent of sunlight present at various depths in a part of an ocean. Find an exponential model to fit the data using the initial condition and one other point in the table. So again, our initial amount is going to be at a depth of 0. The percentage of sunlight is 100%. So here's what we're going to do for this problem. We're going to set it up like this. Again, we want to get a formula in this form, a times b to the x power. Now in this case, remember these numbers represent percentages, and we don't do anything with percents. We always change them to a decimal. So for my initial amount, I'm not going to use 100. I'm going to use 1 whole, or just 1. So now I'm going to pick one other point in this table. It doesn't matter which one I use. Let's just say I use, let's use this one. So 20 and 1.15. So again, our depth, our x is going to be 20, so my exponent is going to be 20. But my percentage is going to be, it's not going to be it's not going to be 1.15. If I change that to a percent and move the decimal place 2 places to the left, so it'll be 0.0115 is what I'm going to use for y. So it's going to be 0.0115 equals my initial amount, which is 100%, which is 1.0, or just 1, times b, and my exponent for b is going to be my x here, which is 20, because when x is 20, y is 0.0115, or 1.15%. So now I'm going to solve this. Now multiplying by 1 or dividing both sides by 1 here isn't going to change anything, so that 1 really isn't necessary. So at this point I want to just get rid of the, because there's no numbers to get rid of next to the b, so I'm just going to take each side to the 20th root, because the 20th root will undo the 20th power, leaving me with b equals the 20th root of 0.0115. When you do that in your calculator, you should get approximate 0.8 when you round it. So again, our goal isn't to find out what b is. Our goal is to figure out an equation that would represent, that would be a good model for this particular problem. So our answer is going to be y equals 1.0. If you want to put the 1.0, you can, or you can leave it out, times 0.8 to the x power. And it's a good idea to always check to see how accurate your model is. So if I take 0.8 on my calculator, I know you can't see that right now, but if I take 0.8 and if I raise that to the, let's say, 40th power, when x is 40, on my calculator I get 0.00013, which as a percent, if I change 0.00013, change it to a percent means I'd move the decimal place over 2 places. I get 0.013 as my answer, which is what we have here for a percentage. Or if I took it to the 10th power, if I take 0.8 to the 10th power, I get 0.107 as my answer, or 10.7%. So it's always good to check and make sure that your model makes sense, because you don't want to assume that your model is correct. That's the nice thing about math, is a lot of times you can check to verify your answer. Now with this particular video, we're going to stop here, because in the rest of these notes, this requires you to use your CAS calculator. So I just wanted to emphasize how to be able to do this by hand here, because that's what the majority of your assignment will be doing. So we'll stop there, and good luck on your assignment.